mathematician. Hope you're doing good. I am Mohini. So whatever we have learned in the previous two videos, we will understand those things in a better way using the examples that is given. So first example that's given is x square plus x minus 2 equal to 0. We have to represent the solution of this in the roster form. So first let's get the solution of this equation. So it's given that x square plus x minus 2 equal to 0. So as you can see, this is a quadratic equation, so you can even use a quadratic equation formula also, or you can factorize also. So let's factorize it. So x square plus 2x minus 2 equal to 0. Grouping it, x common tegidre x plus 2 remains, minus 1 common tegidre x plus 2 remains, which is equal to 0. X plus 2 into x minus 1 equal to 0. So x equal to 1 and x equal to minus 2. So these two are the solution of the given equation. So now we have to represent this in the roster form. So we can write it as 1 comma minus 2. So we have represented the solution of this given equation in roster form. So in the second example, we can see that it is given set of all x such that x is a positive integer and x square is strictly less than 40. Here we have to note two words. One is positive integer, another one is x square strictly less than 40. Because as we know, integers consist of all positive numbers, negative numbers as well as 0, right? And if we square the negative number also, we get a positive number, but they have strictly mentioned that only positive integers. So we have to note all those integers, all those positive integers whose square is strictly less than 40. So what is 0 square? 0 square is nothing but 0, that is strictly less than 40. 1 square is 1, which is strictly less than 40. 2 square is 4, strictly less than 40. 3 square is 9, which is strictly less than 40. 4 square is 16, strictly less than 40. 5 square is 25, strictly less than 40. 6 square is 36, less than 40. And 7 square is 49, that is greater than 40. So we are listing those numbers which are less than 40. So we can write it as 0, 1, 2, 3, 4, 5 and 6. So what about 7? We can't write 7 in this list because 7 square is 49, which is greater than 40. So in the third example, we can see that it is given a equal to 1, 4, 9, 16, 25 and so on. So these are nothing but the square numbers. 1 square is 1, 2 square is 4, 3 square 9, 4 square 16, 5 square 25 and so on. So how can we represent this in the set builder method? The question is to represent this in the set builder method. So we are representing this set in the set builder method. So a can be written as set of all x such that x is a square of a natural number. Or you can also denote it as a equal to x such that, set of all x such that x equal to n square, where n belongs to the set of natural numbers. So if we observe this, we can see that all these are nothing but the positive integers, non-zero positive integers, because 0 is not included. So we can write it as a equal to x such that x is a square of non-zero positive integers. Or we can also write it as a equal to set of all x such that x equal to n square, where n belong to z plus. This denotes the positive integers minus 0 because it is a non-zero positive integer. So in the fourth example, we can see that it is given 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6 and 6 by 7. So we have to represent this in the set builder form, represent this set in the set builder form. So what can we see? We can see if numerator is a number, the denominator is one number greater than the numerator. So if we take the numerator as n, the denominator is one number greater than the numerator. So it becomes n plus 1. Right. So what about n? So n is less than or equal to the number 7, but n is greater than or equal to 1. So we can write this as set of all x such that x equal to n over n plus 1, where n is less than or equal to 7 but greater than or equal to 1, or you can even tell that n running from 1 to 7, both are same. So in the fifth example, it is given match the following, where I have already written the correct answers D, C, A and B. So let me explain the answers for you. So first one, it is given PRINCAL, right, the set of some letters. So by seeing this, we can understand that it is written in the roster form. So in roster form, the elements are listed, elements are separated by commas, and they are enclosed within the flower braces, right? And what are the main things in roster form? The order of the element doesn't matter, and generally the elements are not repeated, that is, the elements are taken as distinct. So this, by seeing this, we can understand that these are the letters of some word. So that is nothing but principle. So this matches, the D matches accurately. So set of all x such that x is a letter of the word principle. So the next one is set 0. So what do we know about 0? 0 is an integer. So whatever the set that we are writing, so it should contain an integer. So option C matches with the second one properly, because see here, set of all x such that x is an integer and x plus 1 equal to 1. Why does this match? Because in x plus 1 equal to 1, the 1 on both the side get cancelled. Plus 1 and plus 1 on both the side get cancelled, and this will be x equal to 0. So this matches with the second one accurately. The next one we have 1, 2, 3, 6, 9 and 18. So what can we see from this? These numbers, what can we observe from these numbers? They are nothing but the divisors of 18. So 1 18s are 18, 2 9s are 18, 3 6s are 18, 6 3s are 18, 9 2s are 18, 18 1s are 18. So the option A matches with the third one properly. So set of all x such that x is a positive integer and is a divisor of 18. So next, fourth one and the last one, we have 3 comma minus 3. So what is this 3 comma minus 3? Option B matches with this 3 comma minus 3, because it is written that the set of all x such that x is an integer, because 3 and minus 3 integers are the only set which contains positive number, negative number and 0. So this contains both positive and a negative number. So we should search for integers, integer word. So set of all x such that x is an integer and x square minus 9 equal to 0. Because see, x square, if you shift this 9 to the other side, it becomes x square equal to 9. And the square going on to other side becomes the square root. X square root of 9. Square root of 9 is nothing but 3. Sorry, plus or minus 3. So plus 3 and minus 3. So option B matches with the fourth one properly. So I hope you understood these examples. So in the next video, we will discuss about the exercise 1.1. Some more problems are given there. And yeah, that's it for the video. Like, share and subscribe, and don't forget to comment. So, ಧನ್ಯವಾದಗಳು.